Okay, now let's focus on our examples, how we handle these horizontal projections. So the question is here, but I've already sketched the diagram as I'm going to take you through. So a ball rolls off the edge of the top of the table 1 meter high above the floor. Now the floor there is going to act as our ground. So you see this is the table 1 meter above the floor with a horizontal velocity of this. Now the velocity is horizontal. That's when it comes to the horizontal projection. Find the time when the ball takes to hit the floor. Now the ball to hit the floor would have covered all this distance from here up there. Now that means that to hit the floor, we are going to consider the vertical motion. So in our vertical motion, okay, what happens? We know that this is our we have there, and then we need the time and when it hits this floor here. So what do we have? We know that we have the distance, and whenever you have the distance, it calls for from our s equal to ut plus a half at squared. So now our distance here is going to be 1 equal to our u. Said whenever you're in vertical motion, our u is 0, then plus a half. Our acceleration to be gravity. Whenever you have this motion downwards, you see it's coming downwards, so our gain is going to be 9.8 meters per second. The acceleration due to gravity. So this is going to be our acceleration. Then t squared. So this would be 1 equal to 4.9 t squared, and from there our t will be, when divide and get the square root, getting 0.45. You can give 2 for decimal places as bar. So that's the time which this will hit the floor there. Now this is our ball. Now the one that's the horizontal distance it covered. Now assuming our ball is here. Now the horizontal distance it covered. So we are going to say from here up to here, we need that horizontal distance. So in simple terms, we are going now to consider the horizontal motion. Now we are talking about the distance. So we are going to use the formula s equal to ut plus a half at squared. Now we said in horizontal, whenever we are moving like this, the speed is going to be the same. So there, our acceleration is going to be 0 meters per second squared, because this speed is going to be constant. So our sx, the distance in the horizontal direction, our u there, where is our u? Our u is here, then the time we have it there already, so our u is going to be 1 times the time, 0.4518, and so our is going to be 0.4518, and these are going to be meters as the distance it will cover. Okay, by the time it reaches there. Okay, then they are asking for the velocity when it hits the floor. When it hits the floor, this is the velocity it's going to be using. So this is the velocity, this is our initial, this is the final velocity which is going to be going. So already we needed to get this Vx, and then we need to get Vy. So in our, this was our part A, this is part B. When we come down to part C, this is what I'm going to be with. So this is going to be my Vy, and then Vx, and this one is going to be my Vy. This is the velocity I'm looking for. So meaning I need to get Vx. So my Vx using this 80. So my V is 1, then plus acceleration. Whenever I see x, it means that it's horizontal motion. So acceleration is 0 t. So our V x is going to be 1 meter per second. Don't forget the units always. Then Vy would be u plus 8t. Whenever you see y, it means that our initial is 0, which would be 0 plus our acceleration, which is 9.8 times the time, 0.4518. So our Vy is going to be 1 4.4276 meters per second. So this is our dy. So to get now our d, you see it will be the square root of vx squared plus vy squared. So my v is going to be here 1 squared plus now 4.4276 squared. So now my v is going to be 4.5391 meters per second. So now this is the velocity at which this particle, this ball, will hit that floor. So now, if they want the direction, so in our direction, we just get that acute angle. This one here, alpha. So you know that our alpha is always given by tan inverse of dy over v of x, which would be tan inverse 4.4276 over 1. And so our alpha will be 77.27 degrees, and this is described as we saw the description. So that's how we handle that. Members, please, what we have to stick on, what happens when we are in horizontal? Whenever in horizontal motion, acceleration is 0. Whenever we are in vertical motion, our inertia is 0. When you know that, then horizontal projections are going to be very easy. Let us go to more examples about this. See you there, but please don't forget to subscribe to the channel. Now, when you are sketching, you always put this so that you can easily see your interpretations of the question. Horizontal, then your balls at this point. Whenever you're at this point, create the horizontal component, create the vertical component, then this is going to be the resultant velocity. So that's it, members. Wish you well.